Moivre's theorem. For any complex number, cos theta plus I sin theta, if it is raised to the power n, cos theta plus I sin theta all raised to n, it will be equal to cos n theta plus I sin n theta. This power will come inside, cos n theta plus I sin theta. So these are the results obtained from this rule. That is why it's corollary. Cos theta minus I sin theta. Instead of plus, if it is minus, here minus. Now, power is negative. Then cos n theta minus I sin n theta. Here, inside minus, power also negative. Now, here it will be plus. Cos n theta plus I sin n theta. Now, here, this is a polar form, cos theta plus I sin theta. Now, instead of that, sin theta plus I cos theta. So that you can take I outside. After that, cos theta. Here, there is no I. So, inside you have to write 1 by I. But 1 by I can be written as minus I. Because 1 by I, if you multiply numerator and denominator by I divided by I square is minus 1. So it can be written as minus I. 1 by I can be written as minus I. If z is cos theta plus I sin theta, show that z raised to n plus 1 by z raised to n is 2 cos n theta. Z raised to n minus 1 by z raised to n is 2I sin n theta. Now z is given. So we have to first get z raised to n. Then you have to get to 1 by z raised to n, then add. So if you remember that step, it is easy to do this sum. Z raised to n. So z you can substitute cos theta plus I sin theta, then raised to n. Then you can apply de Moivre's theorem. As per de Moivre's theorem, this power will come inside. So cos n theta plus I sin n theta. Next we have to get 1 by z raised to n. 1 by z raised to n can be written as z raised to minus n. Z we can write cos theta plus I sin theta, then raised to minus n. Then applying de Moivre's theorem, you will get like this. Because when you take this minus n inside, it will be cos minus n theta. But cos minus n theta is same as cos n theta. Then when it is here, sin minus n theta, but that is equal to minus sin n theta. Now add these two. You have to add. When we add cos n theta plus cos n theta, it will be 2 cos n theta. This term will get cancelled because I sin n theta and minus I sin n theta. This will get cancelled. So it will 2 cos n theta. We are getting this. Next, we have to subtract. From this, you subtract this. So z raised to n minus 1 by z raised to n. When you subtract cos n theta minus cos n theta, this will get cancelled. Then I sin n theta minus I sin n theta. So it will become 2I sin n theta. Simplify sin pi by 6 plus I cos pi by 6 all raised to 18. To simplify, we have to apply de Moivre's theorem. When we apply de Moivre's theorem, real part should be cos function, but here real part is sin function. So sin pi by 6 plus I cos pi by 6 can be written like this. You take this I outside, after that cos pi by 6. Here I is not there, so you have taken I outside, so you have to write 1 by I. But 1 by I can be written as minus I. Now raised to the power 18 both sides. This is to be raised 8. Now I raised to 18. Then I raised to 18 can be written as I raised to 16 then I square, because when power is a multiple of 4, it will be 1. So I raised to 16 will be 1. Now I square is minus 1. Now here we can apply de Moivre's theorem. So this 18 can be written inside. Then 18 and 6 will get cancelled. So 3 pi minus I sine 3 pi. Then cos 3 pi can be written as 2 pi plus pi. Here sine 3 pi can be written as sine 2 pi plus pi. Then cos 2 pi plus pi is same as cos pi. When you add 2 pi, it will not affect the value of the cos function. So cos pi is minus 1. Similarly here sine 2 pi plus pi is same as sine pi. Sine pi is 0. Now you take this minus 1 inside, minus into minus plus, so plus 1, then minus into minus plus, so plus 0i. 1 plus 0i is 1. So after simplification we will get 1. Simplify 1 plus cos 2 theta plus I sin 2 theta divided by 1 plus cos 2 theta minus I sin 2 theta all raised to 30. For this, let us give Z. So Z is equal to cos 2 theta plus I sin 2 theta. Then modulus of Z is square root of cos square 2 theta plus sin square 2 theta. So this is 1. So square root of 1 is 1. So modulus of Z is 1. So modulus of Z square is also 1. Then modulus of Z square is Z conjugate. Z conjugate is equal to 1 by Z. So this is Z. So Z conjugate is cos 2 theta minus I sin 2 theta. Z conjugate is same as 1 by Z. Then for this we can write like this: 1 plus, for cos 2 theta plus I sin 2 theta we can write Z. Then for this we can write 1 by Z. Then 1 into Z is Z, so 1 plus Z divided by Z, so that can be written here. So 1 plus Z will get cancelled, so it will become Z raised to 30. Z we can write cos 2 theta plus I sin 2 theta. Now we can apply de Moivre's theorem. So this 30 can be written inside. So 2 into 30, 60. 2 into 30, 60. So after simplification you will get like this: cos 60 theta plus I sin 60 theta. I hope you understood how to apply de Moivre's theorem to simplify. Thank you for watching.